Welcome back. Let's jump right in. Today's explainer is basically our ultimate quest to master the Google Cloud Professional Machine Learning Engineer certification. We're going to decode the syllabus together and map out the exact roadmap we need.
But seriously, are you ready to architect the future of AI? Hook in, because this isn't just about passing a dry test or memorizing a bunch of facts. This certification is actually an incredibly powerful blueprint for building production-ready, enterprise-grade ML pipelines. Whether you're totally new to Google Cloud or a seasoned data scientist, grasping these concepts is absolutely going to level up your entire approach to machine learning.
All right, let's map out the journey. We've got 5 key sections today: architecting low-code solutions, prototyping and managing data, scaling models for production, serving and automating, and finally, responsible AI. We're essentially following the natural evolution of an ML model, taking it all the way from raw data to a fully automated factory. Starting right off with Section 1, Architecting Low-Code Solutions. You know, it's kind of surprising to realize that you don't always need complex, custom neural network code to build really powerful models. Often, the smartest move is just building AI solutions right where your data already lives. BigQuery ML lets you build linear and binary classification, regression, and even complex time series models using simple SQL-like commands. It's really about working smarter and drastically reducing your time to value.
Now, if we crack open Google's Model Garden, it reveals this massive arsenal of out-of-the-box ML APIs. You've got these incredible pieces you can just instantly plug in, like the Cloud Vision API, natural language, cloud speech, translation, all the way to highly specialized ones like the Document AI API and the Retail API. So the big takeaway here is that you're empowered to solve complex business problems instantly, plugging in world-class AI without reinventing the wheel.
And here's where development gets literally cutting edge. Leveraging Retrieval Augmented Generation, or RAG, using the Vertex AI Agent Builder. With minimal coding or even totally no-code visual tools, you can ground your language models right in your own external knowledge sources. This lets you build comprehensive, highly informed, and context-aware AI applications in record time. It's a total game changer. Moving on to Section 2, Prototyping and Managing Data.
Let's face it, we all know the messy reality of data engineering. You literally have to defeat the monsters of bad data before you can train anything. Pre-processing and engineering features is where this battle is truly won. You'll use robust tools like Dataflow, TensorFlow Extended, or TFX for productionizing your ML pipelines, and of course BigQuery to clean and transform your data. But the absolute key takeaway here is the importance of consolidating all those engineered features into the Vertex AI feature store. It creates a single, reusable source of truth for your entire organization, saving just countless hours of duplicate work.
Next up, we got to figure out our ideal command center for development. Setting up a solid Jupyter Notebook environment is critical. We'll be choosing between Vertex AI Workbench or Dataproc, maybe even leveraging Spark kernels for massive, large-scale data processing. And obviously, we absolutely must seamlessly integrate Git for efficient version control and team collaboration. This is where those raw ideas finally start turning into actual code. But hey, you can't just build in a vacuum, right? You must measure. Tracking ML experiments and evaluating generative AI is absolutely critical. You'll use Vertex AI TensorBoards seamlessly combined with TensorFlow or PyTorch to visualize your model's performance and spot bottlenecks early on. Plus, if you're working with generative AI, you have to rigorously evaluate it, balancing out metrics for accuracy, creativity, and definitely potential bias. Which brings us to Section 3, Scaling Models for Production. All right, the prototyping phase officially over. Now it is time to architect the heavy-duty hardware and infrastructure. First up is selecting the right framework and architecture, and honestly, it's a delicate balancing act. You have to navigate the crucial trade-offs between model complexity and your interpretability requirements. Like, a massive, complex deep learning network might give you the highest accuracy, but if your business, or maybe the law, requires you to explain exactly why a decision was made, well, you might need to step back and choose a simpler, more interpretable framework. Now think of this breakdown as your ultimate infrastructure cheat sheet. We have CPUs for standard compute workloads, GPUs for those complex neural networks, TPUs for massive parallel processing at true Google scale, and edge devices for local low-latency needs. It's also vital to know your distributed training tools, like using Haravad to sync multiple GPUs, and the reduction server to optimize network bandwidth during those massive distributed training runs. Hitting the nail on the head with your hardware choice dictates your project's speed and, frankly, your budget. So what's the essential training checklist to actually scale that model from a local notebook into a production-grade asset? You've got to effectively ingest diverse data types, from simple CSVs up to Hadoop clusters and images. You need to select the right SDKs, like Vertex AI Custom Training or Kubeflow. Then execute those distributed training pipelines, run rigorous hyperparameter tuning to squeeze out literally every drop of performance, and even fine-tune those powerful foundational models straight from the model garden.
Moving right along to Section 4, Serving and Automating Pipelines.
Okay, so the model is trained. Awesome. But we got to deploy it to the world so it doesn't immediately become obsolete. We need to compare our inference strategies. On one hand, we have batch inference. This is perfect for high-throughput, scheduled predictions on massive datasets using Dataflow or Dataproc. On the other hand, we have online inference. This is what you use when you need low-latency, real-time predictions via Vertex AI public or private endpoints. Choosing the right method here is literally the difference between a snappy application and a totally frustrating user experience.
And to handle real-world heavy-hitting traffic, we have to tune those models and scale the backend for peak throughput. Scaling the serving backend using Vertex AI prediction or containerized serving is non-negotiable. You must actively tune your models to optimize for latency, memory, and throughput. This optimization phase, this is exactly what separates a pretty good prototype from a bulletproof enterprise-grade solution.
But the real goal? Upgrading from manual, clunky deployments to full automation. Tracing this journey step by step? Step 1 is organizing your assets cleanly in a model registry. Step 2 is A/B testing different model versions to definitively prove what works best in the wild. Step 3 involves continuously validating your data and models to prevent drift. And Step 4, the whole shebang, is orchestrating the entire end-to-end MLOps lifecycle with CI/CD pipelines using tools like Kubeflow, Vertex AI Pipelines, or Cloud Composer.
Finally, Section 5, Championing Responsible AI.
We're bringing it to the ethical core now. This is a really important principle of the whole ML lifecycle, because getting this wrong can cost a business millions and, frankly, instantly destroy user trust. We absolutely need to safeguard privacy, security, and fairness. That means handling sensitive PII, personally identifiable information, and PHI responsibly with strict anonymization. Plus, we have to bake tight security practices right into our development environments, like Colab Enterprise and Vertex AI Workbench, just to make sure the models we're building are transparent and fair from day one.
So we've traveled through the entire ML lifecycle together today. You've seen the low-code shortcuts, the rigorous data prototyping, the heavy-duty hardware scaling, the automation pipelines, and those absolutely crucial responsible AI guardrails. You have the blueprint. So the only question left is, what will you build? I challenge you to take this roadmap, crush the PMLE exam, and start architecting the responsible, automated, and brilliant future of AI on Google Cloud. Thanks for joining me on this explainer, and keep building.